For the last presentation for this morning's session. We have Justin Baker, who is the manager of CSIRO's visualisation and collaboration team as part of the e-research program, and Peter Tyson, who is the principal architect of CSIRO's remote visualisation system. Justin and Peter will be presenting CSIRO's remote visualisation capability.
Great. Thank you very much for that. That's right, Peter. I can work from there. Thank you. Okay. Hello, everyone. So I'm Justin Baker, and I'm going to talk a bit about CSIRO's remote visualisation capability. And Peter's bravely going to try and give a demonstration at the end of the talk, so hopefully that'll behave itself. Now, I know this slide's been around. I've already seen it a few times myself during the conference, but basically just to reinforce the fact that CSIRO is a fairly complicated organisation. We've got over 6,000 staff. I think it's even maybe 56 locations around Australia. And CSIRO also works across an amazing range of different disciplines, some of which are that have overlapping interests and some kind of completely separate to others. And probably each and every one of these is having to deal with this, potentially exponential increase in data size and complexity. So it's sort of into that whole complex environment that we've got the CSIRO e-research program. And the e-research program is really aimed at sort of supporting the science workflow. So it delivers enterprise-wide services, solutions and software to tackle some of the issues I was talking about before. So basically it flows all the way from research planning through collaboration, data collection, data management, computation like high performance computing, through discovery and all the way down to publication of results and data. In this particular instance, it's the discovery component that I'll be talking about and specifically the advanced visualisation service. So, as it says at the bottom there, visualisation is recognised as one of several key enabling technologies as far as this goes. So the advanced visualisation service actually delivers a number of capabilities or supports a number of capabilities. Remote visualisation, which I'll talk about further. We've also developed a way of doing tiled displays, looking at different technologies to do that. So basically a way of visualising very high resolution data using multiple screens or even projectors. And you can see a picture of a tiled display down in the bottom corner there. Stereoscopic display systems, so if you're looking at true 3D data, how do you go about doing that and how do we deliver that to the researchers? Some interesting issues there. We're moving more into the application support and consulting space. So up until now we've focused really on delivery of computational systems specifically around visualisation, but equally important, perhaps more so, is actually working with researchers, taking their data, reformatting it, maybe generating animations or putting it in a form suitable that they can then use it to collaborate with other researchers. We're slowly building up a library of advanced visualisation software packages, mostly open source, but we've got a few commercial packages as well. And we're also providing facilitated access to other visualisation, other partner systems, visualisation facilities. And the top image in the top corner there is the 3D Alive immersive visualisation facility at Monash Uni that CSIRO is a partner in. So remote visualisation, I guess, is virtualised access to dedicated 3D graphics hardware. And if you can get it right, there are a number of significant advantages to actually trying to deliver the capability. Probably the most obvious one is the reduced need to have local visualisation workstations. They're relatively expensive systems, they need maintenance themselves, generate heat and so on, and it's yet another system that we need to maintain. So if you can have a shared visualisation resource, that's obviously a better way of using the computing equipment. Remote vis is, generally speaking, I guess by definition, is largely transparent to the application. So you can fire up the application and often has no knowledge of the fact it's running any differently locally versus on a remote visualisation system. We're using VNC as the clients in most cases, and that has this shared remote collaborative capability. So you could, say, pull up a volumetric data set and work with a colleague or multiple colleagues at different locations, and you can all get in real time and interact with the data in different ways. Another advantage, of course, is the fact that you're not restricted to a particular platform. So Windows users, for example, could have access to a whole range of visualisation software on Linux, or potentially vice versa. I think a really important need is the fact that you don't need to push huge volumes of data around. So potentially you could generate very large data sets, say on HPC high-performance computing systems, and then work on them very close by on the visualisation systems as well, without having to drag data backwards and forwards across the network. The solutions we've actually been looking at run on relatively low bandwidth networks, and to prove that we'll give you a demonstration in a moment. And some of the technology also supports stereoscopic, true 3D stereoscopic as well, even in a remote capability. So on the Linux side, we had a look around at what was on offer, and it seemed fairly clear that VirtualGL, this is an open source project, provides the best capability for virtualised graphics. And this is specifically for OpenGL applications, which is where most scientific applications seem to be targeted. VirtualGL also supports this shared collaborative viewing capability that I was talking about before. And as a spin-off there, as I said previously, it basically opens up a whole range of Linux applications to people who may, up until now, only be working in the Windows space. We've also been using another product called VisStack, which is a sort of resourcing tool for GPU sharing. So basically you can have multiple users on a single node all sharing the same GPU, the graphics hardware. And there are fairly simple ways where those users using that software can also, say, request a whole node or a whole GPU. So it's fairly sophisticated in the way it works. And VisStack itself also supports these sort of upper-level constructs like tiled displays, which obviously could be useful in some instances. On the Windows side, we initially thought VirtualBox would be the solution. VirtualBox is another virtualization application, and basically it is itself an OpenGL application. So our idea was just to run, say, Windows virtual machines using VirtualBox on top of VirtualGL, and then everybody would be happy. It would all be supported within the same platform. We found it did actually work well for some applications, but others didn't work at all. There was some strange behaviour with texture mapping and a few minor issues that in the end convinced us it was probably not a workable solution. Another big player in the Windows area is RemoteFX, which came out I think about a year ago with GPU enabled access for remote desktop. But that's primarily focused around DirectX applications, so not a lot of use as far as OpenGL goes. I think it does have some OpenGL support, but for quite an old version of OpenGL. So more recently we've been looking at Citrix, the Zen desktop solution from Citrix. And once again we've had some issues with that, but it seems the latest release, which is 5.5 there, came out about a month ago, does actually do what we're after. And so we've been deploying some Windows Remote Viz systems based on this, and so far they seem to be working quite well. So in terms of operational systems, we've had a Linux remote visualization system operational for about a year now. And as I say, we've recently deployed the Windows side using the Zen desktop. And in both cases it's very simple. You sit at your desktop, fire up a client of some sort, and generally presented with a desktop which everybody's familiar with, and then you can launch your applications and go and find your data. We've got a number of different applications installed for various, to address different discipline requirements. And over time, we're slowly picking up more and more researchers within CSIRO as word spreads about how useful the system is and the fact people don't have to administer it themselves. Another interesting point actually for remote visualisation is it's not just your PC that you can use as the endpoint where you do your work, but it also works in most cases equally well on very high resolution displays like tiled displays. So there's a kind of simple conceptual diagram here. You can see the remote viz cluster, the nodes over on the side there. And I guess what I'm just trying to demonstrate here is you could have a single user on their PC who's running some application, doing some visualisation and rendering. But you can also have shared sessions, so they could be between two people with PCs, similarly configured. Or alternatively, they could be on completely different viz-type platforms. So this could be one person on a very large tiled display working with someone on a PC, or multiple tiled displays, which we've also experimented with. And mostly that works quite well and the performance is pretty good. So, as I say, we're building up our user base internally within CSIRO, and these are some of the packages and uses that we've seen so far. So Maya and Insight are being used for some computational fluid dynamics type work. ParaView is a more general application that's being used by a few different groups for visualising very large data sets. Some mining people in Western Australia are interested in using some software called Leapfrog, which does nice sort of rendering of rock faces and stresses and so on. And we have a few users using Drishti and more recently a VisoFire to view synchrotron like tomography data and do volumetric display and analysis with that. And another interesting one, there's an open source network analysis program called Cytoscape, which you can see down in the bottom corner there, which is like a network. These guys are using it for sort of genome regulation, I think, mapping out the way information flows between different genes across genomes. They're standing in front of the big tiled display there, proudly displaying what they've created. So, future plans, I guess, what we'd really like to do is bring the visualisation systems that we've got more closely in line with our HPC systems. At the moment, they're mostly fairly separate, so you would go and work on them. You might take your data that you generated on an HPC system to one of these and do some sort of analysis, and then you may need to go back to your HPC system after that and do some more work. We're keen to bring the two much more closely together. But there's obviously some interesting issues with that. The high-performance computing systems are generally batch-driven, whereas Viz is obviously almost exclusively an interactive way of working. One idea is to have persistent sessions, so basically the researcher would come and they would always have somewhere where they could do some sort of, even if it's lightweight, but visualisation that's then coupled with a high-performance computing system. And then we need to think about just how the networks are integrated between remote viz and HPC, and how we make use of the high-performance file systems like Lustre. Another thing we haven't got to yet, but could happen down the track, is maybe doing computational steering, so kind of adjusting compute jobs as they run in real time, maybe looking at the output and making some changes which actually affects the computation and then feeds back into the whole process. On the Windows side, there are some limitations, not major ones, I wouldn't say at this stage. The software we've got limits one user per GPU, which is a fairly expensive way to go if this took off in a big way. There's no simple way of doing this collaborative sharing on the Windows side that I was talking about before. So there are a number of Windows applications around that do let you do that. TeamViewer seems to be quite a good one, and we're having a bit of a look at that as a way of addressing that issue. And Windows doesn't provide, the Windows solution we're looking at doesn't have a stereoscopic capability. So I might just ask Peter if he can come up and give us a quick demo. Well, just before he launches into that, I just mentioned we've got the AusViz visualisation workshop, and there's an accelerated computing workshop coming up later this month in November. So if you're interested, either let me know, or it's easy to find on the internet if you just do a search around. So thanks. Peter?
Yeah, well, typically with the Linux-based system, a user would log into a system as we see here. Issue a very simple command to start a session. Which will allocate a certain amount of resources. And we can see a session set up here with a one-time password that we can then connect to. And here we are in with a Linux desktop here, which we then can just execute applications with icons. And this is Drishti here, produced at ANU, which is quite a good volume rendering application. Could load some data into it. This is a multi-gigabyte file here, so the way Drishti works, you need it loads all the data into the video memory, so you need a big video card to be able to not lose any resolution. So, which is beyond most PCs, it's a data set we're seeing here. This doesn't look great, so I made a few functions. We can just see different aspects of the data here that I've coloured in different ways. This is actually a small tube with sand and water and oil inside, and the water was pushed through to see what happened to the oil. So as you can see, even across the wireless here, back into the csiro network via a encrypted tunnel, the performance isn't bad at all.
So that I should add, Peter used like a little one-time password, and all you need to do is give that to your collaborator. And basically they use the same VNC clients, and they can get into the same session as yourself, and they'd interact with the data in the same way. So what we've actually been doing is using, say, Evo, for example, as the video conferencing tool that goes side by side with this. We could even do it with the phone. So researchers can chat with one another and interact with the data in real time. And as Peter showed us there, fairly large data sets behave themselves quite well with this technology.
Yeah, that's right. So we have a range of applications installed on the system here. There's something else showing the responsiveness of it. This does use lossy compression, so you do lose, you can tailor the compression to the connection speed, so you have a bit of a trade-off of losing a bit of data. And this window here that we've started up can be an arbitrary size, so if we're on a larger display, we can just size it to whatever size we would like, and so forth. So.
Okay, thank you very much.
Thank you very much.
Oh,
Justin,
thank you.
and Peter. Okay, any questions for Justin and Peter? Yes.
In this demo, apart from not on the GPUs, and can there be GPUs and or nodes inside a cluster, not only nodes where you do
Well, these nodes are a cluster themselves, so you can run MPI jobs, for example, across these nodes. And we have some scripts, for example, with ParaView, that a user can just type a simple command and start up a number of back-end nodes, how many workers, how many processes each node you run on. So, yeah, you can.
Like when you were starting the session, that's the system of allocating GPUs. And can this allocate GPUs on the nodes inside the cluster or just
Yeah, no, well, so we logged into the head node here, and so those GPUs could be allocated on any node in the cluster, wherever there's a free node, yeah. And I grabbed the whole node there, so it starts an X server on 2 of the, both GPUs on the node. So it depends what you're doing. If you're running CUDA or something like that, you won't necessarily need an X server, but yeah, so you can anywhere along the cluster. Yeah.
Okay, I had a couple of questions, if I might. So you said that visualisation is seen as a significant enabler in the e-research program.
Mm-hmm.
What size team have you got looking after, if you're able to, if you don't mind talking about that you've got looking after that part of the program?
Sure, most of us are here.
Okay.
Yes, that is one. We have another person in Canberra, and we're taking on hopefully another resource sometime soon. It's only a small group at the moment.
And are you finding demand is manageable, or are you sort of managing the growth of demand in a way?
Yeah, I think it's being managed. So we, as I say, because we're a small team, we're probably bringing in the demand in a rate that we can deal with it. That makes sense, rather than just throwing open the floodgates and inviting 6,000 staff to suddenly jump on board.
Right. And so as far as being able to collaborate, or are there opportunities for working with you, or is some of this available or being shared or with other organisations?
Well, these are all effectively either open source or freely accessible projects, so anybody else is free to adopt them, but we'd be happy to speak to other people about ways of interacting and collaborating. In fact, I think that'd be great.
Okay. Well, thank you very much, Justin and Peter. I just